All right. So really quickly, let's review this information and see how much you remember. Okay? If the derivative is positive, what do you tell me about the original function? It's increasing. If the derivative is negative, the original function is decreasing. If the derivative changes from negative to positive, the function changes from what?
Decreasing.
Negative to positive.
Decreasing.
Decreasing to increasing, therefore causing it to have a what?
Minimum.
A minimum, a relative minimum at that value, right? If the function changes from increasing to decreasing, what can you tell me about the derivative?
Changing negative.
The derivative changes from positive to negative, right? And it has a relative maximum, very good. And usually it'll have a relative max or a min when the derivative is equal to what? To 0, very good. Pretty good? That's what we talked about on Friday, that's about as far as we got. And then we started talking about drawing or coming up with a derivative graph, right? Yes? This function right here is what we call a quartic function. What would this one be called? Cubic, okay? So remember that the derivative should always be 1 degree what?
Less.
1 degree less. So if I had a quadratic function here, what would the derivative of that quadratic function be? What's 1 degree less than quadratic?
Linear.
Linear, very good. What if I had something linear? What would be 1 degree less than linear? Constant, okay? So especially on those problems on the AP test where they ask you to match the graph with its derivative, that's one way of eliminating answer choices really quickly. Oh, it's cubic, my derivative has to be quadratic. I have to have a parabola. Get rid of the ones that aren't. Oh, my function is linear, my derivative has to be constant. Get rid of the ones that aren't. You understand? So that's one giveaway. The other giveaways are the actual specifics regarding your graph. So that's what you have to look at. Pretty good? What did we say we wanted to think of the derivative graph as? A list of slopes, right? So up here on the top, what can you tell me about these slopes? They're all what?
Positive.
Out of these would be a list of positive slopes, right? And how about the slopes that are listed here on the x-axis? Those are zero slopes, right? And how about the slopes that are down here?
Negative slopes.
Negative slopes. Okay, so it's important for you to be able to understand that. Good? Alright, so what we're going to do is we're going to explore a little bit more. We're going to look at the derivative graph now and see if we can answer questions about the original function. What happened? Can't sharpen your pencil? Came out all awkward? It looks perfectly fine to me.
I also came out all awkward.
I don't know what's awkward about it.
What?
You're saying it's different.
I don't know.
That's why the instructions are there.
What?
Oh, that's why there's instructions, yeah. Oh, okay. Alright, so if we look here, what is it that they're giving us in this particular example? They're giving us what? The derivative. So this is not the graph of the original function. This is the graph of what? H prime of x, right? And we said that this was a list of what? Of slopes. Okay? So what do we have up here on the top? What kind of slopes? These are positive slopes because they're above the what? X-axis. If they're on the x-axis, they're what?
Zero slopes.
Zero slopes. So can we label where it has zero slopes? Because that's also something good to know. Where does it have a slope of 0?
Negative.
Negative 2, 1, and 3. So what does that mean? When the derivative, when the slopes are 0, what does that mean about the original function?
It has a relative.
It's going to have a relative max or a relative min, right? So it could have a max or a min here, a max or a min here, a max or a min here. It's not going to have a max here. Okay, don't read the graph like that. Okay, this just means that the slope at -1 is what? 5. That's all it means, because it's a list. You understand? That's not a maximum. It's a maximum for this particular graph, but it's not a maximum on my original graph. You understand? Yes? We're going to think of this as a maximum later on when we start talking about the second derivative. Now I'm going to look at this graph the way I looked at the original graph. Yes? So it's going to get interesting, okay? How about down here? What kind of slopes are these? Negative slopes. Good? So we got positive slopes, 0 slopes, and negative slopes. Awesome. Alright, could you tell me what h prime of 2 is? -2? Very good. How did you get that answer? It's a list of slopes. So you went to 2 on the h prime graph, which is this one, right? And then you found the y, which was what? -2. So what would this mean in English to somebody reading it? What could we say? The slope of what? Of the tangent line of what? H of x, the original graph, at x equals 2 is -2. That's what that means in English, okay? If I read this statement, that's what I need to think. Oh, this is telling me that the slope of the tangent line of the original function h of x at x equals 2 is what? -2. Okay? That's why we invented these mathematical symbols to not have to write all that out. Okay? Boom, that's a little bit easier to write than that, but you have to understand what it means. Good? Alright. So let's go through these questions and let's see if we can answer them, okay? Now, what I want you to remember is anytime they give you a graph, okay, this is the graph of what? H prime, okay? All my answers need to be answered using this particular graph. Okay, so they have to go back and refer to H prime. I have to use H prime graph as a justification for my answer. Do you understand? But sometimes in order to answer a question, I need to think of what H prime means in terms of H of x. So I need to go backwards. Let's look at it and I'll help you come up with your thinking, okay? So what is the first question asking? The intervals where h of x is what? Okay, the problem is we don't know h of x. H of x is the original function, right? So how could I do it?
Wherever it's positive.
Very good, okay? So we know if h of x is increasing, then what? Using what I'm given, then h prime of x has to be what? Greater than 0, meaning it's what? Positive. Okay? And how am I going to know where the derivatives are positive up here? Good, above the x-axis. Did we label it right? This is where they're positive, right? Okay? So all these intervals where it's positive is going to be where the original function is increasing, okay? So let's write that down. If h prime of x is greater than 0, then its graph is above the what? The x-axis, which occurs on what intervals? Can you tell me from where to where this derivative graph is above the x-axis? Where is the slopes positive? -2 to 1, okay, and
3 to infinity.
3 to infinity. We good? Yeah? So I'll highlight it, okay? I'm gonna highlight where h prime of x is greater than 0. That orange color. Easy? Sort of? You have to change your thinking, okay? Now let's look at the next one. What do they want? H is decreasing, right? So is that like right here? Because it's going down. No, why is it not that? This isn't the original graph, right? This is a list of slopes, right? So how do I know where the function is decreasing? Why below? Very good. So if h of x is decreasing, then h prime of x has to be less than what? 0, meaning it's what? Negative. And if h prime of x has to be less than 0, its graph must be where? Below the x-axis. Which occurs where? Where is it going to be below the x-axis? Where's the derivative less than 0?
Negative infinity to 2.
Negative infinity to negative 2. Okay, good. Union 1 to 3. Good. Right here to right here. Got it?
Much cheating.
Got it?
What?
Pretty easy? Let's answer the next question. Where does h of x have a relative what? Maximum. Okay? What has to be true for me to have a maximum?
You must go from increasing from positive to negative.
The slope has to be positive, so it has to be positive.
The derivative has to change from what?
Positive to negative.
So the original function goes from increasing to decreasing. The derivative changes from positive to
Negative.
negative, right? Okay, so let's think about that for a while. So h of x has a relative max, right? When h prime
Was that you?
No, it was outside.
It's outside.
when h prime of x changes from what? From positive to negative. And I have to always refer and think about how can I determine that using the derivative, because that's the graph that I have. Do you understand? Okay, so that's why I keep referencing h prime. Yes? So if we think about that, where is the graph going? It's going from being where to where?
From the.
Good. So count from what?
From like.
From above
the x.
the x-axis to below the x-axis. Again, looking at only the what? Derivative graph, right? Because we're trying to go from some positive number to some negative. So where does it change from being above the x-axis to being below? At negative 2? No, it changes from being where? Below to above, right?
From negative 1.
Nope, not at negative 1. At negative 1, it's above the x-axis only, right? At 1, right? Here is where it's changing from being a positive number to being a what? Negative number. Okay, so that means that at what number should I have a max at? At 1. You told me that that's where my maxes would be, where my slopes were what? 0, right? So it has to be at one of these yellow points. Understand? In order to determine that, I have to check what's happening around it, right? Okay? So, what does that mean? So h prime of x changes from positive to negative its graph goes from where? From above
Oh,
to below the x-axis, which occurs at,
no, max.
right? It has a max, but where is it gonna occur at? What x value? X equals 1, right? We said it went from a positive value to a negative value. You with me? Yes? So what do you think the idea for a minimum is gonna be?
From negative x value.
Very good. Why from below to above? The derivative has to go from a negative to a positive, right? Okay, good. So let's write that down. H of x has a relative min when h prime of x changes from negative to positive. Its graph goes from below